Today's topic is rate equations. Also, we are going to calculate the half-life period of any reaction, half-life period or time taken for the 3/4 of conversion or any number of conversions. What types of problems they may be asking in this section? First, we will give the general equation for this rate equation, general equation. And the nth order from this equation you can calculate for any order of the reaction, nth order equation. This general equation is not applicable to the first order kinetics. General equation is not applicable to the first order kinetics. First, make a note of it. Therefore, we are giving separately the general equation for nth order and the first order kinetics. First one, the differential form. That is rate minus d of changing the concentration of A by dt. That is nothing but the rate of the reaction is equal to Kn into A power n. This is the single reagent, single reactant is present. Therefore, we have given as only one reactant and the nth power of the reaction. Therefore, here the rate constant is given as the nth order reaction. This is a differential form. In the differential form, the first order and the nth order are equivalent. Minus d of A by dt is equal to K into A. K1 into A. K1 represents the first order kinetic. And this also we can write down a graphical representation for this one. The rate is equal to Kn into A power n. Here two variables are there. Rate is going on changing. Therefore, it is let us assume it is y. Here k is a constant. The concentration of A we taken is maybe going on changing. Therefore, this one. And if you plot this for the zero order reaction, what is the zero order reaction? Here this is equal to 0. Therefore, A power 0 is equal to this. Therefore, rate, this is the y, we call it as the rate. Rate versus A with concentration. The rate is equal to the rate constant. For which order reaction, the rate of the reaction is equal to its rate constant for a zero order reaction. It is constant whatever may be the initial concentration taken. The graphical representation will be there. Whenever the rate is plotted against the concentration of the initial concentration of A, it is found to be parallel to the x-axis, and for such things, what would be the slope of the reaction? The slope of the reaction, you know all things, the slope of the reaction is equal to 0. For a second order, the equation is changed into K2 power A by 2, A power 2. If you plot for this one, for a second order, what is the rate, differential rate form? Minus dA by dt is equal to K2 power K2 into A power 2. Therefore, if you take it as y, and if you take as a whole as x, and this is a constant m, y is equal to mx. Therefore, here you have to plot y instead of y, the rate. Instead of x, you have to plot A power 2. And as the concentration A changes, you will get a straight line without no y-intercept. Therefore, this starting from the origin, and the m slope is going to be positive. Therefore, this is going on increasing. The slope is nothing but K2. Therefore, slope is equal to K2 for a second order. For a third order, once again, this power 3, K3, and here if you plot A power 3 and you are getting a straight line, this equation, the order of the reaction, this one. If you apply for this one, if the equation is not parallel, it is not passing through any origin, a zigzag would be there, no straight line will be applying for a third order result. Similarly, if you apply for the second order, once again you won't get a straight line. So this is called the graphical method of determining the order of the reaction. This is from the differential form. Similarly, you can apply the graphical representation for integrated form, exponential form, and so on. And now we will give another thing in the integral form. This is very essential to work out the problems. Integral form. The equation is Kn into T is equal to 1 by n minus 1. 1 by n minus 1 into 1 by at power n minus 1 minus 1 by a naught power n minus 1. What is a naught? What is at? A naught is nothing but the initial concentration of the reactant. Here we are considering only one reactant is there in the reaction. And at is the amount left after the time t. Amount left is equal to a naught minus x. X is the amount reacted at the time t. But at is the amount left remaining in the reaction medium after the time t. Therefore, in the place of at, you can also put a0 minus x, and x, the amount consumed, may be asked for that purpose. At should be substituted with a naught minus x. This is the integral form of this one. What is the integral form of it? Here the first order reaction. K1 is equal to 2.3 into log of 2.3 into log of a naught by at. This is the integral form. Instead of at, you can also put at is equal to a naught minus x. In the place you can put like this. This is the integral form. For a zero order reaction, if you are asked a zero order reaction, immediately you can derive that equation from this. Put n put 0. Your equation would be k0 into t is equal to 1 by minus 1 by 1 by at power minus 1 minus 1 by a naught power minus 1. If you like this, minus into at power minus 1 is written as at minus a naught. Bring this one, you will get a naught minus at. Therefore, this is the integral form of the rate equation for the zero order reaction. From this, you can calculate a0 or the time taken for that conversion or the amount left after that time. This is for a zero order reaction. For a first order reaction, you can't apply for the first order reaction because when you have put 1 in the end, 1 minus 1 is equal to what is 0, 1 divided by 0, anything divided by 0 is infinity. It's ill-defined. Therefore, the general order equation is not applicable to first order. Instead, we have arrived at the method, and that is the equation we are adapting this one. And for this integrated form can also be given in terms of graphical representation. Here, if you bring two variables, t is a variable, bring the constant here a naught by k naught and at by k naught. Here, a naught by k naught is a constant, c, t is a variable, at is a variable, and 1 by k naught is this one. And it is in the form of, if you take the t in the y-axis, and this is the c constant, this is the m and at. Here you should plot the time versus at. You will get definitely a straight line with the intercept, and that slope of that intercept should be a negative. Therefore, you will get a graph like this. Or you can rearrange this equation in such a manner that bring AT, the amount left after time t, and you should bring this here A0 minus K0 into t. Am I correct? This is brought into this is brought to this. Now AT is in the y-axis and it's a constant, it is a constant, t is a variable. It is in the form of C minus K0 into t is the x-axis. This y is equal to this one, or it is equal to C minus Mx. Therefore, now you have to plot AT here and T here. Once again, you will get a straight line. And the straight line at 0 time, A0 is the intercept, you will get the, and a negative slope. And the slope here it is equal to minus K0. Here slope is equal to minus 1 by K0. That's the difference between this and this. Therefore, any form can be rearranged. And what is the y-axis it is given? What is the parameter in the x-axis given? Accordingly, you should rearrange it. And you may ask, when I plot AT versus T versus zero order reaction, the slope is equal to plus K0 minus K0 plus 1 by K0 or minus 1 by K0. They may ask in two more questions, for which you have to rearrange like this. Therefore, note what is the parameter plotted in the y-axis, what is the parameter plotted in the x-axis. Accordingly, the standard equation should be manipulated and you can easily plot this one. This is the graphical representation for zero order. You can extend this graphical representation for any order. Now we will go for a second order equation. What's the rate equation for the second order reaction? Apply to all the places. A2 into T is equal to 1 by 1 into 1 by AT minus 1 by A0. This is for the second order reaction. And instead of AT, you may be also putting A0 minus X, where X is the amount reacted. If you want to calculate the amount reacted, you can calculate what is the amount left in the reaction. Subtract from the original concentration, you will get the amount there. Therefore, you make use of this equation itself. And for some other case, if you want to this, you will make use of this here also. This equation is changed into 1 by AT by 1 by A0. What is the graphical representation? Here the graphical representation is, if you take T in the y-axis and AT, 1 by AT should be given in the x-axis. Or otherwise you can rearrange this equation such that 1 by A0 plus K2 into T equal to 1 by AT. Now you have to plot 1 by AT versus T, 1 by AT in the y-axis and T versus in the x-axis. You will get a straight line with a positive slope with the intercept. It is not passing through the origin intercept, that intercept is equal to 1 by A0, then 1 by AT versus T is plotted. Instead, somebody may ask you to calculate AT versus 1 by T, AT versus 1 by T. Accordingly, you have to manipulate this equation. You have to invert this equation. How to invert this equation? Before inversion, you should know this inversion factor. Take A0 as the factor, A0 into K2T. Now invert this, you will get A0 by 1 plus A0 to K2T. And if you simplify, you can also simplify. One can consider to be compared to this, it is equivalent to less. Then the equation is simplified as K2 into T. This and this cancel. Now AT is equal to this one. Now plot AT versus 1 by T. You will get a straight line passing through the origin and with a positive slope. The slope is equal to 1 by KT. And you can manipulate in any manner And accordingly, what they have asked, they have plotted this. Accordingly, you can derive the equation, find out what is the result, what is the intercept, what is this one, and so on. And the exponential form, the exponential form. The exponential form is not applicable for this. It is applicable for the first order kinetics, and the concentration left at the time E is equal to A0 to E power KT. This is this one. Here also, if you plot this one, and you know this is E power is the negative, therefore the value would be going on decreasing as K is a constant, T is increasing. Therefore, if you plot AT, the amount left after the time T, you will get an exponential decrease. The exponential decrease, the value would not be reaching to 100%. Would not be reaching to 100%. It is approaching. Therefore, what is the time taken for the completion of the first order reaction? So not only first order and above the first order reaction, no reaction will be 100% completely covered. It is taking infinite time. Only one order reaction which would be completed 100% is the zero order reaction. For the zero order reaction, the rate is independent of the initial concentration. That's another nature. For the zero order reaction, the rate is equal to the rate constant. It is also another nature. Therefore, the zero order reaction is nearly entirely different from other orders. In what way they are different? Go and check your notebook. You will come across that one. And next, from this you can calculate the reaction completion time. The reaction completion time is given by the equation. Reaction completion time. How much completion? T 100%. T 100%. That is for 100% of the reaction. If you want to put this one 100% reaction time, Kn, general equation Kn, T 100% is equal to 1 by n into A naught power n minus 1. This is the equation, 100%. Here, note the change here. Here only it is changed. Here only it is changed. Put n is equal to 1, n is equal to 0, T 100%, time taken for 100% completion by 1 into A naught, 0 minus 1 minus 1 by Kn, or it is equal to A naught by K0. This is the time taken for completion. For other reactions, for first order it is not applicable. If you put the first order 1 minus 1 equal to 0, everything multiplied by 0 is 0 divided by 0, it is taking infinite time. It is taking infinite time. Similarly, put n is equal to 2, its a negative value would be approaching. And the time taken for 100% negative value is not possible. It is also the infinite time would be taken. Therefore, only order of the reaction that is 100% completed is the zero order. What is the equation for that one? T 100% for zero order is this one. Or this is the general equation. This is only for zero order. There is a finite time for completion of 100%. For all order, it will take infinite time. After the next, we are going to see this T 50% completion. And you can substitute the 50% completion in this, and you will get a general equation Kn T 50%. That can be derived from this itself. Kn T 50% is equal to the same equation 1 by n minus 1. 1 by n minus 1 by 1 A naught n minus 1 into 2 power n minus 1 minus 1. This is the general equation. You can memorize this equation. From this, you can derive the T half for various orders. Go and work out. Put T for zero order, put zero everywhere. Find out what is the equation for the T half for a zero order. And want to know for the second order, put n is equal to 2 everywhere. Find out, rearrange the equation. You will arrive at the equation for the T half of the reaction for second order. Or you want to know the 1.5 order. Put n is equal to 1.5 everywhere. You can calculate what is the T half equation for 1.5 order and so on. And this equation is not once again applicable to the first order reaction for which it is given as K. T half equal to 0.693 by K1. And what is the speciality here, Adina? It is the only order of the reaction in which it is independent. The T half is independent of the initial concentration. Whatever may be the concentration, the time taken, initial concentration, the time taken for half of the reaction to be completed, the time is remaining constant. For example, if you have taken 1 kilogram of a reactant A for a first order kinetic, it is converted into 0.5 kilos, that is 50% conversion. 2 hours is required, let us assume. And now we have taken 100 kilograms. What is the half of it? 50 kilograms. How much time it is required? Same 2 hours. Therefore, the reaction in which the half-life period is independent of the initial concentration means you can boldly say that order of the reaction is the first order. Whereas all other orders, zero order or first order, second order, fractional order, it is depending upon the initial concentration. Very, very essential. And next is the time required for 70% completion. It is equal to, the general equation is Kn. T 75% is equal to the same equation 1 by n minus 1 into 1 by n of n minus 1 into 2 power n minus 1 minus 1 into only one term 2n minus 1 plus 1. This is for 75% completion. And what is the same equation for here? See, 75% completion is equal to, this is twice the times you should multiply it, 2 times higher, therefore it is equal to 1.386 by K1. And the next thing they will be always asking is, what is the relationship between T75% and T50%? What is the relationship? They may ask. They will give the time taken for 75%. You may be asked to calculate what is the time taken for 50% conversion for the same order of the reaction. Or they will give the time taken for 75%, the time taken for 50%. If this is the case, what is the order of the reaction? For all of them, you can't remember individual order equation. You should keep the general order and you can easily work out the problem. What is the relationship? That is, if you compare this and this, compare these two, these terms are present in the T50% itself. Therefore, the relationship is T75% is equal to 2 power n minus 1 plus 1 into T50%. This is the relationship. If 2 times are given, it is easy for you to calculate what is the order of the reaction. If this time is given, order is given, you may be asked to calculate 50%. And don't think that only the 50, 75 or 100% would be asked. 100% would not be asked for any other order except the zero order. They may ask, what is the relationship between 50% and T 99.9% or T 10% and T 40%. This general equation cannot be applied. For that, you should go by the individual rate equation from which we can calculate, and we will work out some problem in this also. And this is the general equation, and the last general equation is the amount left after new number of half-life period. Problem will be easily asked in this. How much amount is left after new number of half-life period? 5 half-life period, or 1 half-life period, or 1.5 half-life period, etc. That is given by the general equation. AT is equal to A naught into square root into root of n minus 1 to root of n minus 1 to root of 2 power n minus 1 minus 1 into mu plus the result is added with 1. This is the formula. And for the first order, it cannot be applied. For which the separate order is AT is equal to A naught by 2 power mu. These are the general equation. For each and general equation, you can apply various problems. Using this general equation, now I am going to calculate the order of the reaction. The order of the reaction can be calculated using the half-life period method. We have already given. The half-life method is how to identify this half-life method and how is it possible. And for this, note the half-life method is here. And if you take the T 50% is equal to, for a given order n minus 1, it is a constant. For a given order, this would be becoming a constant by A naught into n minus 1. Initial concentration would be a varying quantity. We are taking this one. And 2 power n minus 1 for a given order, it is also a constant quantity. And minus 1 is a constant. Therefore, which is variable divided by Kn. Kn, it is also for a given reaction. It's a constant. Therefore, removing the constant, we can write this T 50% directly proportional to, inversely proportional to 1 by A naught into n minus 1. A naught into n minus 1. This is a simplified equation. We are going to use this equation to calculate the order of the reaction. Because to calculate the order of the reaction, you have to give two different initial concentrations. What about their half-life period? If the half-life periods are given, two sets of equation, you apply these 2 times and you can find out the order of the reaction. This is the methodology we are following here. Before seeing this methodology, you can apply this T 50% for zero order. What is the equation? Put n is equal to 0, A0 minus 1. Therefore, T 50% is equal to A naught power 1. And for the first order, T 50% for first order, what happened? 1 minus 1 A naught or T 50% is equal to A naught power naught. That is independent of the initial concentration for first order. For zero order, it is directly proportional. Therefore, whenever the initial concentration increases, the T half also increases. That means that the order is zero. Proportionality increases. It's not equal to proportionality. The second order, if you put the second order, it is found that put 2 here, it is inversely proportional to A naught. As concentration increases, the T-half value for a second reaction decreases proportionately. For a third order reaction, T50% would be inversely proportional to A naught square. For fourth order, A naught 3. For fifth order, and so on. Here, as the square function is there, therefore the variation is not in a linear manner as we discussed here. Here also linearly increases, here linearly decreases, but here it is 5 times it decreases, 2 times it increases, drastically decreases. Therefore, if you look out this, just to look out what is the variation between this 50% and the initial concentration, without doing any calculation, you can see this is the zero order because only for zero order it is going on increasing as the initial concentration increases. For a first order, it is independent of the initial concentration. For a second order, inversely proportionately decreases as concentration increases. For third order, it is 5 times it is decreasing. And using this simplified equation, we are going to use the calculate the order of the reaction. Take down the question. HI decomposes. HI decomposes to hydrogen and iodine. Hydrogen and iodine. When the initial concentration of HI is, 0.1 atmosphere, 0.1 atmosphere. The half-life time of the reaction is 135 minutes. 135 minutes. When the initial pressure is 1 atmosphere, when the initial pressure is 1 atmosphere, the half-life time decreases 1/10 time. Decreases 1/10 time. 1/10 time. அப்படின்னாலே உங்களுக்கு தெரிஞ்சிருக்கும். 1/10 டைம்னா என்னது? இதுக்கு குறைஞ்சிக்கிட்டு வருது. அப்போ 13.5 minutes. 1/10 டைம்னா 13.5. இது எவ்வளவு கூடி இருக்கு? 10 மடங்கு கூடி இருக்கு. கூட கூட இது குறைஞ்சிருக்கு. அப்படின்னா என்ன அர்த்தம்? It is not a first order, it is not a zero order, it may be a second order or it may be a third order and so on. In the second order, it is inversely decreased. It is inversely proportionately decreases. இங்கே எத்தனை மடங்கு கூடுதோ அத்தனை மடங்கு இங்கு குறையும். இதே செகண்ட் ஆர் தேர்ட் ஆர்டரா இருந்தால் இங்க எத்தனை மடங்கு கூடியதோ அதனுடைய ஸ்கொயர் டைம்ஸ் இது குறையும் அப்படின்னு நம்ம படிச்சோம். இப்ப அதை பார்த்துக்கிட்டீங்கன்னா எந்த ஆர்டர் சொல்லிடலாமா? இந்த ஆப்ஷன் இஸ் ஜீரோ ஆர்டர், ஆர் செகண்ட் ஆர்டர், சி தேர்ட் ஆர்டர், டி ஃபர்ஸ்ட் ஆர்டர். இதுல எது இல்லாதது எதெல்லாம் கிடையாதுன்னு உடனே சொல்லிடுங்க. இனிஷியல் கான்சன்ட்ரேஷன் இன்க்ரீசஸ், the time is also increased, means it is zero order. No change in the T-half means it is first order. It is proportionately decreases means the second order. It is proportionally concentration increases square times na 1 by square times third order and so on. If you know this, you can, without doing the problem, you can see what is the order of the reaction. So what is the order of the reaction? Anybody? It is a second order reaction because 10 times increases, therefore 10 times it decreases. It's a second order because I have given the general equation for the second order. It is inversely proportional 1 by A naught. If you work out, now let us work out this. The methodology you should follow for the class purpose. Here we are doing 2 sets of data. Use these 2 sets. and one said it's 135 minutes is directly proportional to 1 by, this order is not given, 1 by A is 0.1 power n minus 1. And the second set of data, it is 13.5, 1/10 time it decreases, therefore 13.5 is proportional to 1 by initial concentration is 1 power n minus 1. 1 divided by another 135 by 13.5 is equal to, this is nothing here, it is given as 1 by 0.1 power n minus 1. Or you can write it as 0.1 power 1 minus n also. It is equal to 10 times. It is equal to 10 times. And how to convert this? Whether you should convert this into the base 10 or you should convert into the base 10. It is easier to convert to the base 10. How? It is equal to 10 power minus 1 power 1 minus n. That is nothing but 10 power n minus 1. This is 10. Therefore, n minus 1 is equal to 1 and n is equal to 2. This is the methodology. You should follow this. And but looking into the data, you can also give whether it's a first order or the second order or zero order. But fractional order is given, it is not easier to give by mental sum, you have to work out it. Now do the next problem. The D half of your reaction, the D half of your reaction is halved. HALVED, halved. As the initial concentration of the reactant, is doubled. What is the order of the reaction? Option 0, 1, 2, 3. Initial concentration என்னன்னு கொடுக்கல, நாமளே வச்சுக்கிடுவோம் C, and half life period கொடுக்கல, T half வச்சுக்கிடுவோம். ஓகே, அதுக்கு பிறகு கொடுத்திருக்கிறத பாருங்க. இந்த T half reaction is halved as the initial concentration is doubled. 2C மாறி இருக்கு, இது பாதியாக குறைந்து விடுகின்றது. What is the order of the reaction? கொடுத்திருக்கிற ப்ராப்ளத்தை I have given in terms of the data. What is the order of the reaction? சொல்லுங்க பார்க்கலாம். Order of the reaction is பார்த்த மாத்திரத்திலே சொல்லிடலாம். 0, 1, 2, 3, 4 option. What is the order of the reaction? Somebody else? It's the second order. ஏன்னா second order தான் என்னது 1 by A0. 2 times கூடிச்சுன்னா 2 times கூடிச்சுன்னா அங்க half time இருக்குன்னு சொல்லியிருக்கோம். இங்க குறைஞ்சதுன்னா அங்க கூடிரும், இங்க கூடுனா ப்ரொபோர்ஷனேட்டா இதுவும் ஃபார் செகண்ட் ஆர்டர். பார்த்த மாத்திரத்திலே சொல்றீங்க. And another is the half-life of a reaction is doubled. The half-life of a reaction is doubled as the initial concentration of the reactant is doubled. As the initial concentration of the reaction is doubled. What is the order of the reaction?
Zero order.
Zero order. இன்னெல்லாம் அதுக்கு ப்ராப்ளமே போட வேண்டியது இல்லையா? Next problem. The following data were obtained. For the decomposition of a compound at 580 degrees centigrade, A0 mole per liter, T half in seconds, 0.5, 4,280. When the initial concentration is 1.1, it is 885. When it is 2.48, it is 174. Determine the order of the reaction. Determine the order of the reaction and the rate constant of the reaction. We are increasing the difficulty level, order of the reaction, and the rate constant. And see this, look at the problem. At initial concentration 0.52, it is increased 2 times, it's not. If it is increased 2 times, the rate constant is decreased. Therefore, it is not definitely zero order, not definitely first order, and it is not definitely the second order. Why? If 2 times increase, the rate constant should be 2 times decrease, but the deca is 4,280, but it is even at 885. Therefore, it may be how many times it decreasing, observe it, how many times it is decreasing. And from this, whether it is possible to work out that one, or you have to go by the methodology, some methodology that we are going to adopt. That methodology is nothing but T half is directly proportional to N0 power N minus 1. First apply this one. T half is 4,280 is directly proportional to the initial concentration 0.5 power 1 minus N. This is the first data. Take the second data, 885 is directly proportional to 1.1 power 1 by N. இதுல எல்லாம் இருக்கு, என்ன மட்டும்தான் வேணும், N. 1 divided by another தான் போட்டுக்கிட வேண்டியது. 1 divided by anotherனா இதை போட்டுருவோமா, இப்படியே போட்டுருவோமா, இப்படி போட்டோமா என்ன ஆகும், ஈக்குவல் டு இதால வகுத்தா கிட்டத்தட்ட எவ்வளவு இருக்குப்பா பார்த்து சொன்னீங்கன்னா கிட்டத்தட்ட 5 பக்கத்துல இருக்கா, பட் இட் இஸ் நாட் எக்ஸாக்ட்லி 5. இட் இஸ் நியர்லி எவ்வளவு இருக்குன்னு ஒரு அப்ராக்சிமேட்டா நம்ம இதை அப்ளை பண்ணுங்க. 4.3 into 10 power 3 divided by 8.9 into 10 power 2. இதை 9 போட்டுட்டு இதுக்கு 4.25 அப்படின்னு போட்டீங்கன்னா கிட்டத்தட்ட என்ன வருது, 5 வரல, 9 4 36 65 கிட்டத்தட்ட 7, 4.7 or 4.8. 4.8 is equal to இதை போட்டீங்கன்னா என்ன வரும், 2.2 in power 1 minus N. ரைட்டாப்பா? And 4.8 2.2 இந்த பேஸ்ல ஏதாவது கொண்டு வர முடியுமா? அழகா கொண்டு வரலாம். This 4.8 can be written as 2.2 power 2 அப்படின்னு கொண்டு வந்துடலாம். 2.2 ஸ்கொயர் ஆஃப் தி ஏன்னு 2.2 ஸ்கொயர் பண்ணி பார்த்தீங்கன்னா உங்களுக்கு அந்த இது வரும். நம்ம ஸ்கொயர் டேபிள் எடுத்து போடுங்க. This can be written as 2 power 2 power n minus 1. கீழே இருக்கிறத மேல கொண்டு வரேன். It is n minus 1. Okay. Therefore, n minus 1 is equal to 2. Therefore, what is the n? N is equal to third order. Thus, we can easily calculate this one. Here, order alone is not odd. You are asked to calculate. என்ன calculate பண்ண சொல்லியிருக்காங்க. You have to calculate the rate constant. And it is a third order, you have to give the rate constant equation and the T half and rate constant. What is the rate constant for the T half? Derive that equation. The T half இருந்து கொண்டு போங்க. General equation T half is equal to அப்படின்னு சொல்லி ஒரு இது கொடுத்துருப்போங்க. Kn is equal to 1 by n minus 1 into 1 by n0 n minus 1 into 2 power n minus 1 minus 1. It's a general equation for the half-life. இதுக்கு எவ்வளவுன்னு கொண்டு போங்க பார்க்கலாம். Increasing difficulty level in the problem. கொண்டு வந்தா என்ன வருது பாருங்க. put n is equal to 3 in the everywhere, you will get k3 t half is equal to 1 by 2 by 1 by a naught 2 into 2 power 2 minus 1 equal to 3 by 2 into 1 by a naught square. K3 is equal to 3 by 2 by 1 by a naught square into 1 by t half, and put any one of the initial concentration and find out this 3 by 2 into initial concentration. Let us put it as 0.5 square divided by t half, which is 4280. 3 by 2 into this 0.5 is nothing but 4 into 1 by 1480. கிட்டத்தட்ட என்ன ஆன்சர் வரும்? 1.4 into 10 power minus 3 வருதான்னு பாருங்க.
And then 0 into 10 raised to
10 power minus 3 இல்லையா? Therefore, this is the answer for this. This is a very difficult level problem. Finding the order itself is going to be difficult. But what is the rate constant? You have to derive the relationship between the T half and the rate constant from the general one. Then you have to proceed like this. And now I will give you another type of problem from which you have to calculate the order of the reaction. Or take down the another type of problem. The concentration of a species A undergoing the reaction A giving T is 1.5, 0.33, 0.25 mole per dm cube at T is equal to 0, 1, 2, and 3 seconds respectively. Find the order of the reaction. Option: second order, first order, zero order, and third order. This is the problem given. A 4-mark question, I think so. And give me the answer for this. And this is the initial concentration. And the time taken is 1 second for the half-life. Okay. If the initial concentration is 0.5, let us assume initial concentration is 0.5, and the concentration is 1 second decrease 0.25. The time taken is 2 times it is increase, and the concentration is 2 times it decrease, it is increase. இதுக்கு பாருங்க 1 second. இந்த initial concentration வச்சு இதை பார்த்தோம்னா this one. Now we have taken, this is a half-life period, this is another half-life period. We are not considering this at all. And using this, you can find out what would be the order of the reaction. என்ன ஆர்டர் இருக்கும் சொல்றீங்க? சொல்லுங்க பார்க்கலாம். ஆர்டர் சொல்லுங்க. நான் புரியலையா? What is order?
Second order.
Second order reaction. For concentration. ஒன்னுல இருந்து பார்க்கும் பொழுது 1. This converter this. If we take this as the initial concentration, convert this it is into 2 times. 2 seconds it is there. இது எப்ப நம்ம 1 second, இது 2 second increase. But concentration is 2 times decrease. Therefore, what is the order of the reaction? இது 4 மார்க் கொஸ்டின். ஆனா இதை பார்த்த உடனே நம்ம கண்டுபிடிக்க மாட்டோம். ஆனா பை ஹாஃப் லைஃப் மெத்தட் we can easily identify. அதனால you should have a analysis over the given data. This and this, this and this. You can apply the half life period. ரெண்டு செட் ஆஃப் டேட்டா வந்துட்டு பை ப்ரொசீஜர் நீங்க போங்க. T half is directly proportional to A0 power 1 minus n, and for this half life period 1 second is proportional to the initial concentration 1 power 1 minus n. For this half life period, it is 2 second, initial concentration is 0.5 power 1 minus n. Therefore 1 divided by 2 is equal to 1 divided by 0.5 power 1 minus n. இதையும் போட்டீங்கன்னா 2 power 1 minus n, and it is equal to 2 power minus 1. 1 minus n is equal to minus 1, and n is minus n is equal to minus 2. N is equal to 2. And in this way you can work out, or just looking into this you can find the answer which is present. But you should understand the concept present. And the another methodology, they are using the graphical method. Also, we can determine the order of the reaction. What is the graphical method? And no problem is asked so far, I think so. But however, write down the methodology of this one. And in the half-life method, we have derived the one equation. What is the equation we derived? T half is directly proportional to, write down the equation, T half is directly proportional to A naught power 1 minus n. A naught power 1 minus n. And here from this equation, general equation, we are going to derive this equation. And the derivation is not necessary, but you know the derivation, then only you will understand the graphical representation. And T naught is equal to this one. Or we can write it as T half is equal to, let it be some constant K prime, A in power 1 minus n. Take log on both sides, log of T half equal to log of K prime plus 1 minus n into log of A naught. Log of A naught. Now you can plot this. How it is possible to plot this? Which is a variable? A prime is a constant. Log T half is a variable. And the initial concentration A naught is a variable. Order of the reaction. And the T half for a given order, A naught is going on changing. T half is to be going on changing, except the zero order. This equation is not applicable to the zero order. Here, variable is y. It is a constant, let it be c, and it is a variable, it is x. For a given order, it is a constant mx. Therefore, if you plot this, you will get a straight line. When will you get a plot? Log of T half is equal to mx. X is equal to log of A naught. And you will get a this one, and you will get a straight line with a positive slope, this one. For which reaction is a positive slope? 1 minus n. Or எப்ப வந்து n is equal to a positive slope ஆக இருக்க முடியும்? For n is equal to n and m is equal to 1. Not, then only m is positive. This is applicable for a zero order reaction. For n is equal to 1, m is equal to 0, 0 into 0, therefore this equation, you will get a y value is remaining constant. Therefore, the log of T half versus the x is remaining a constant. Because x is becoming 0, y is equal to 0, The sec மற்றபடி அப்படியே வரப்போகுது. Put n is equal to 2, the value will be changed into negative. Therefore, for a second order reaction, you will be having an equation, a straight line equation for a second order. Put x is equal to log of a naught. Log of a naught. This is for first order. This is for second order. For n is equal to 3, the slope is still decreased. Therefore, if you put what is this, the steeping would be there and so on. It's going on increasing for n is equal to 4 and so on. And after obtaining this, what is the angle it makes with respect to x-axis? Parallelly increase this one. Parallelly increase this one. This is the angle observed. Generally, you should measure the angle from this reference axis in the anti-clockwise direction. If you measure this in the anti-clockwise direction, it's a positive theta. If you measure in the, here the angle is 0 degree. Here 45 degree varum, or first order 0 degree. For this, here you are going to measure the angle இங்க இருந்து ஆக்சுவலா எப்படி மெஷர் பண்ணிருக்கணும். This is the angle you measure. Or you can also measure the angle in the reverse direction also. If you measure this, we call it as the minus theta in the clockwise direction with respect to a reference axis. If you measure in the clockwise direction, it is a minus. Therefore, here also it is going on change. The theta is the negative value, the theta is going on changing. Therefore, if you compare this result for order changes, the angle with which the straight line obtained is going on changing. And the slope of this line is nothing but 1 by n. Therefore, slope is equal to 1 by n. But the slope is nothing but tan theta of plane, being a tan theta. Therefore, tan theta is equal to 1 minus n. Therefore, if you know what is the theta value, you can calculate what is the R of the reaction. The problem will be asked in this way. Take down the problem. When log of T half for a given log of T half for a given reaction is plotted against the initial concentration of the reactants, we get a straight line with a negative slope, and the angle of inclination is found to be minus 63.43 degree. Angle of inclination is found to be minus 63.43. Determine the order of the reaction. This theta is given, tan theta is equal to 1 minus n. When log of T half is plotted against log of A0, the slope is equal to 1 minus n. Therefore, tan of minus 63.43 is equal to 1 minus n. What is the tan of minus 63.31? It is equivalent to minus 2. Equal to 2 means 1 minus n is equal to 2. Bring what is the value of n. You will get what is the value of n. N is equal to third order. Or you can memorize the things, immediately tell the answer. When theta is equal to 45 degree, the order of the reaction is tan 45 is equal to tan 45 is equal to 1 equal to 1 minus n. Therefore, what is the value of n? N is equal to
0.
0 order. Therefore, whenever theta is given as 45 degree, it is a 0 order. Whenever theta is equal to 0, tan 0 is equal to what? Tan 0 is equal to what? Tan 0 Calculator work out 0. 0 is equal to 1 minus n. Therefore, what is the order of the reaction? First order. Therefore, 0 degree. அப்படின்னு கொடுத்தாலே நீங்க உடனே ஆன்சரை சொல்லிடலாம். First order. For second order, the theta is equal to minus 45. Theta is equal to minus 45. And theta minus 45 is equal to minus 1 equal to 1 minus n. Therefore, what is the value of n? It is second order. For a third order, it is minus 63.43. Third order 63.43. For fourth order, minus 71.6. But fourth order reaction, you know, is very, very, very less, very rare. What is an example for a fourth order reaction? Go and search and keep it in your mind. And fifth order, theta is equal to minus 76 degree. And sixth order, minus 80.5. Therefore, if any problem is asked giving that theta, immediately you can say not necessary to find a tan theta value. I'll give another type of problem. Take down the problem. The time taken for 75 and 50% completion. 75 and 50% completion of a reaction. The time taken of 75 and 50% completion of the reaction are 30 and 10 minutes respectively. 30 and 10 minutes respectively. What is the order of the reaction? What is the order of the reaction? Option போட்டுக்கோங்க. 0, first order, 1.5 added, and second order. Now this problem can be done only when you know the relationship between T of 75% completion and time taken for 50% completion. We have given the general equation. What is the equation given? T 75% is equal to 2 power n minus 1. So what is the relationship given? 2 power n minus 1. அங்கே இல்லாதது 50% இல்லாத ஒரு டேர்ம் சொன்னேன். n minus 1 plus 1 into T 50%. Which already I have told you that this may be asked, then you will be given the order of the reaction and the time taken for 50% completion. Or if it is given and the order is given from which you can calculate the time required for 50% completion. Or this time and this times are given, you may be asked to calculate the order of the reaction. Now the problem given is these three types of problem may be asked using this formula. And now it is given the time taken for this 30 minutes and 2n minus 1 plus 1. The time taken for this is going to be 10 minutes. And therefore 2 power n minus 1 plus 1 is equal to 3. Or 2 power n minus 1 is equal to 2. Or n minus 1 is equal to 1. And n is equal to 2. Do you follow this?
Yes, sir.
Okay, if you understand this problem, work out the problem. With this problem, we will close our session. The time taken for 75% and 50% completion of a reaction. 75% and 50% completion of the reaction. Or 25.5 and 15 minutes respectively. 25.5 and 15 minutes respectively. What is the order of the reaction? Option A, 0, B, 0.5, C, 1, D, 1.5, 1.5 added. Work out and find out the answer. 25.5 divided by 50 is equal to 2 power n minus 1 plus 1. 25.5 by 15 is equal to how much? Tell me. 1.7. 1.7. Okay. Then bring the one the other side. Now your answer would be, now your relationship is 2 power n minus 1 is equal to 0.7, is not? But 0.7 can be rewritten as 2 power n minus 1 is equal to 1 by 0.414. 0.7 is equal to 1 by 1.414. 1.414 is nothing but 2 power half. Therefore, your relationship is now 2 power n minus 1 is equal to 2 power minus half. Therefore, n minus 1 is equal to minus half and n is equal to half. Your manipulation here done is a little bit crucial one. And with this, we finish the general equation. And tomorrow's session, shall we give various problems with respect to a particular order for a zero order reactions? What are the problems that can be asked for a first order reaction or a second order reaction? And for up to third order reaction, we will give some of the problems